Hey guys, this is going to be the lesson for the first section in Chapter 6. Chapter 6 is going to be all about polygons, and this first section is called the Polygon Angle Sum Theorems. The first thing I want to talk about is basically what kinds of polygons that there are. There's just a basic normal polygon where there's no specific characteristics about it, and those are the ones that you're used to seeing or used to drawing. But then you also have what's called an equilateral polygon, which is this first one listed, and that means that all of the sides have equal length. Then you have what's called an equiangular polygon, which is a polygon where all of the angles have the same measure. And then you have what's called a regular polygon, and a regular polygon is an equilateral and equiangular combined as one. So if all of the sides and all of the angles all have the same exact measure of each other, then that polygon is what we would consider a regular polygon. There's two theorems and one corollary that you need to make sure that you know, and these are going to be used pretty frequently for this section and for this chapter actually. The first one is Theorem 6-1. It's called the Polygon Angle Sum Theorem, and this theorem says that if you were trying to find the sum of the measures of the interior angles of an n-gon, which n-gon is just a way to list all polygons. So n is the number of sides. So if I was trying to find the measure of an interior angle of a pentagon, for example, then I would use the equation n minus 2 times 180. So n would be 5 in this case. 5 minus 2 is 3, 3 times 180, and then I would get my answer. The corollary to that is that if you're trying to find each interior angle, this is each individual angle, just one angle measure. The theorem is for the sum of all of them. If you're trying to find one, you're going to do that same exact equation, n minus 2 times 180, but this time you're going to divide it by n. So pentagon would be 5 minus 2 times 180 divided by 5. So those two equations are going to become, you're going to want to get very familiar with them, have them memorized, and know how to use them. The second theorem that you need to know is called the Polygon Exterior Angle Sum Theorem, and this theorem basically says that if you have a polygon, the sum of all of the angles, all of the exterior angles, is going to be 360. So we know that it's exterior because it's on the outside of the angle. So you can see angle 1, 2, 3, 4, and 5, they're on the outside. And they're created by extending one of the sides past the vertex. And that's how you create the exterior angle. If you were to add all of those angles, you would end up getting 360 degrees. So any exterior or any polygon's exterior angles will always sum to 360. Alright, so here's two quick examples of finding the sum of the interior angles and each interior angle, so one individual one of the polygons that are listed below. Octagon, that obviously has 8 sides, so we're going to use the formula n minus 2 times 180, but we're going to plug in 8 for n. So this is going to be 8 minus 2 times 180. 8 minus 2 is 6. 6 times 180 is going to be 1080. So the sum of all of the interior angles of a polygon will be 1080. Of an octagon will always be 1080. And that's always the case. Any octagon that you ever have, if you add up the interior angles, that will always end up being the case. For a 20gon, there really isn't a name for 20gon, that's why we call it 20gon. We're going to do the same thing here. 20 minus 2 times 180. 20 minus 2 is 18, and 18 times 180 is 3,240. So 18 times 180 is 3,240. Okay, here's another example of using the Polygon Angle Sum Theorem. This time we're given a polygon and we're giving 4 of the 5 measures or angle measures, and we're asked to find the 5th. And in this case, since this is not a quadrilateral, obviously quadrilateral we know is 360, we're going to actually have to do a little bit of work here. This is a pentagon, it has 5 sides, which means that we're going to need to first use the n minus 2 times 180 equation. And what that's going to do is allow us to figure out how many degrees all of the angles are, and then we can add up the ones that we know and subtract that from the answer that we get from this equation, and that's going to give us angle y. So angle T is 110, angle O is 90, angle D is 120, angle A is 150. There's 5 sides, so this is going to be 5 minus 2 times 180, which is 3 times 180. And 3 times 180 is 540. And so if we add up 110, 150, 120, and 190, that is actually going to be 470. So 470 plus angle y is equal to 540. Subtract 470 from both sides, and we get angle y, which is 70 degrees. Okay, so our last example is going to be this particular one. I've tried to mark the picture, did the best I could. I marked it as a regular polygon, and I know that because all of the angles have one arc, and all of the sides have one tick mark. And this is actually an octagon, so this would be what we would call a regular octagon. If we were trying to find one of the exterior angles, knowing that it's regular tells us that all of the angles are the exact same measure. They're all congruent. So if we were to take the sum of the exterior angles, which earlier we said is 360, and divide that by the number of sides, which in this case is 8, that would allow us to get the number of degrees that each angle is. So in this case, angle 1 would be 45 degrees, as well as angle 2, 3, 4, 5, 6, 7, and 8. They would all be 45 degrees. Tomorrow in class, I'm going to have a question for you as a warm-up question that I'll come around and check as a daily grade. So make sure you take good notes. This stuff really is pretty simple. If you need extra, there are virtual nerd tutorials on the Pearson website that you can have access to, or you can come see me in the morning, after school, or at lunch. Have a good afternoon, and I will see you tomorrow.